For our last few examples, we're going to do the process we've been doing in reverse. Starting with the solution, we're going to come up with the differential equation. Y equals c1 e to the negative 4x plus c2 e to the negative 3x. So we see that the auxiliary equation would have roots m equals negative 4 or negative 3, which means that the auxiliary equation itself is m plus 4 times m plus 3 is equal to 0. Foiling that gives us m squared plus 7m plus 12 is equal to 0. And that's the auxiliary equation for the differential equation y double prime plus 7y prime plus 12 is equal to 0. Yeah, that's what we're being asked to do at this point. On to the next. We've got y equals c1 e to the 10x plus c2x e to the 10x. Now remember what that x means, right? That showed up because we had a repeated root to the auxiliary equation. Therefore, the auxiliary equation is going to be m minus 10, the quantity squared, is equal to 0, which when expanded gives m squared minus 20m plus 100 equals 0. And the differential equation y double prime minus 20y prime plus 100y is equal to 0. Next up, we have y equals c1 plus c2 e to the 2x cosine 5x plus c3 e to the 2x sine of 5x. A couple of things to observe from here. Number one, since we have c1, c2, and c3, we should note that this is a third order differential equation. Number two, the presence of simply c1 means that one of our solutions, call it y1, is e to the 0x. That's how we get a constant. And so that implies that one root to the auxiliary equation is m equals 0. Finally, the presence of e to the 2x cosine 5x and e to the 2x sine 5x also give us roots of the auxiliary equation m equals 2 plus or minus 5i. Our auxiliary equation is then m times the quantity of m minus the quantity 2 plus 5i times m minus the quantity 2 minus 5i equals 0. I want to focus just on the imaginary or the complex roots here for the auxiliary equation. And we can multiply all these out, FOIL, all that stuff, but I'm going to show you maybe a little bit of a more elegant approach. Distributing the negative in both of these sets of parentheses, we get m minus 2 minus 5i times m minus 2 plus 5i. And if we look at this, we've got m minus 2 in both of these, and we have 5i in both of these. And so what we really have is m minus 2, the quantity squared, minus 5i, the thing squared. It's a difference of squares, which then becomes m squared minus 4m plus 4 plus 25. Now, there was an m out in front of the whole thing, and the whole thing was equal to 0. So I'm going to wrap that structure of equation around there. And we have m cubed minus 4m squared plus 29m is equal to 0 is just kind of a slick way to handle that. Now, this was supposed to be a differential equation. This being its auxiliary equation tells us the differential equation is y triple prime minus 4y double prime plus 29y prime is equal to 0.